modeling for MPP Columnar Stores. Would dimensional modeling techniques typically used for analytics still be relevant, or are there more optimal, less rigid data models for MPP Columnar Stores that they can enable? In order to answer this question, let us quickly understand the underlying architecture that MPP Columnar Stores have followed, and we can follow that up with the key advantages that MPP Columnar Stores bring. So here in this slide, we can see the architecture of MPP Columnar Stores. MPP, as the acronym, it stands for Massively Parallel Processing, and MPPs are shared nothing architecture. That's what they have. Unlike data warehouse appliances, which have shared everything or shared disk architecture, which do not scale well, MPPs, they consist or they are based on shared nothing architecture. Here, each and every node is independent and is self-sufficient. Basically, this architecture consists of a cluster wherein you have the master or the leader node, the compute nodes, and then you have a network fabric that is known as the interconnect. The master or the leader node, which is seen in the center, typically it could be anywhere, it's just for diagrammatic purpose. The main function of the master or the leader node is that it interacts with the clients, distributes workload among the compute nodes, parses the queries, generates execution plans, keeps track of data distribution, aggregates intermediate results from the nodes and stitches them together before sending it to the client. Compute nodes, on the other hand, they store data and they compute the data locally. They store data locally. That is important to know. Interconnect, that is the network fabric that joins and is the key to communication between the leader node and the compute nodes. This is a private network and it is optimized for having high bandwidth and high redundancy as well. Some examples of MPP Columnar Stores include HP Vertica, EMC Greenplum, Paracel Analytic Database from Actian, CalPond, Amazon Redshift, and this is just to name a few. We have Teradata as well. We have IBM Netezza. Microsoft has its own parallel data warehouse, which is also MPP based. Columnar databases have a different way of physically storing data as compared to row-based databases. Now, not all MPP systems are columnar, but today we will basically cover those which are both MPP as well as columnar. Columnar databases have an entirely different way of physically storing data as compared to row-based databases. And in this diagram, you can see that this is a typical table structure. In a row-based database, the entire row gets stored in a block. But in a columnar store, it is a column which gets stored. So employee number, which is 1, 2, 3, 4, 5, and going on to 6, all of the entire column gets stored into one or multiple column level blocks. Now this enables better compression, and MPP Columnar Stores, they also employ deduplication algorithms on top of this compression. Columnar stores or columnar databases, they also support native analytics. Native being out of the box, aggregation and analytics are based on column data and not row data. As a result, columnar stores, they support native analytics. In row-oriented databases, the size of the table itself affects query performance. When a specific column is queried, even then the row gets fetched, scanned, because of the entire because the entire level of I/O operation is the row in row-based databases. But that is not the case for columnar databases. And also, one of the main advantages as compared to row-based is columnar stores do not need maintenance and fine-tuning for performance. They do not need indexes. They do not need views. I have one more small diagram out here at the bottom, wherein a select query is being performed. On the left-hand side, it's a row-based. On the right-hand side, it's a columnar approach. In the left-hand side, even though the row-based database uses an index, still it goes to the row, captures the entire row, and then it fetches it and shows it to the client. But on the right-hand side, columnar databases, they simply do the scans on the columnar level, and as a result, the performance is way much faster, way much better over row-based databases. Not only this, it simplifies storage and database administrative tasks as well, the columnar stores. The reason being, you don't need indexes, you don't need views, materialized views, various other database maintenance objects. Now that we have seen the architecture,